On example 4, we're given different polynomials to factor. So let's review the techniques and let's get started. In part A, we have a trinomial. The leading coefficient is 1. So you want to remember that we can think of this constant term as a product. Negative 28 is a product of two values. And the coefficient of the middle term, negative 3, well, that's going to be the sum. When you factor a trinomial, we're going to get the product of two binomials. What multiplies to make q squared is q times q. So now let's fill in the blanks with these numbers. One way to think about this is to start by listing all the factors of negative 28. It's a good idea to start with 1 because 1 is a factor of every number. So 1 times negative 28 will make negative 28. 2 times negative 14 will make negative 28. Keep going in order. 3 doesn't go into negative 28 evenly. 4 times negative 7 goes in, multiplies to negative 28. So 5 doesn't work, 6 doesn't work, and 7. 7 goes into negative 28, but you notice we already have a number 7 written down. So what that means is we're done listing the numbers. Now we just need to consider different signs. For example, negative 1 times positive 28 also equals negative 28, as does negative 2 times 14 and negative 4 times 7. So we want to find which pair of these numbers multiplies to negative 28 and at the same time adds to negative 3. And you can see the pair that fits this description is the 4 and the negative 7. So we can fill in the blanks with a positive 4 plus 4 and the negative 7 minus 7. Now, it will be a good idea to check our answer to make sure we did this correctly. So let's see. To check, we can multiply our factors. We should get q squared minus 3q minus 28. Let's check. Q plus 4 times q minus 7. So you distribute. Q times q makes q squared. Q times negative 7 makes negative 7q. 4 times q is plus 4q. 4 times negative 7 is negative 28. Combine the like terms, and you get q squared minus 3q minus 28. All right, that's a winner. So we'll make our answer stand out. And we're done with part A. Hopefully this was helpful in refreshing your memory. Now let's take a look at part B. There's two ways to look at this problem. Number one is you could recognize that this is the difference of two perfect squares. And if you remember, the difference of two perfect squares factor into conjugates. So what multiplies to make r squared is r times r. What multiplies by itself to make 625? Well, 25 and 25. And to make these conjugates, we'll have plus in one factor, minus in the other. Now maybe you didn't recognize that this was the difference of two perfect squares. Well, then here's another way to look at the same problem. We can rewrite this using the middle term that's missing. We can say r squared plus 0 times r minus 625. We know trinomials factor into the product of two binomials. And let's see, r times r will make r squared. Now you just have to ask yourself, what multiplies to negative 625 and at the same time adds to 0? And that will be a plus 25 and a minus 25. So either way you look at it, we get the same answer. Now part C. Part C is trickier on two fronts. Number one, there's a typo. So if you're going to factor this, try to work this problem as it is, we combine the like terms, the plus 7 and the minus 6. So 3x squared plus 1. This is prime. Can't be factored. But there's a typo. We didn't intend for you to have this prime polynomial. What we meant to have is the middle term be 7x. So please put the x in there. And we're going to talk about how to factor a trinomial whose leading coefficient is not 1. Now, when I was in high school, the way we did this was by guessing and checking. That's fine if that's how you like to do these problems. But I'm going to show you an algorithm that will work anytime you have a trinomial whose leading coefficient is different than 1. Here's what we'll do. Let's start by multiplying the leading coefficient times the constant term. 3 times negative 6 is negative 18. So let's list the factors of negative 18 and find which pair adds to positive 7. So we got 1 and negative 18, 2 and negative 9, 3 and negative 6, negative 1 and 18, negative 2 and 9, negative 3 and 6. And you can see the pair that multiplies the negative 18 at the same time adds to the middle coefficient, positive 7. Well, that pair is going to be negative 2 and positive 9. So here's what we're going to do. We're going to split this negative 18 up into a negative 2 and a positive 9. Negative 2 and plus 9. Now remember, we wanted these terms to add up to the middle term, plus 7x. So let's make this a negative 2x and a positive 9x. Now these will add to 7x, the middle term. Okay, now what we'll do is bring down the first term, 3x squared, and bring down the last term, minus 6. Our next move is to think of this as a polynomial in two groups. The first two terms make a group, and the last two terms make a group. Now we need to look, what can be factored out of the first group? You see there's an x in each term, so we factor out an x, and we're left with 3x minus 2 on the inside. Now look at the second group. What can be factored here? Well, we can take a positive 3 out of each group, and that will leave 3x minus 2 on the inside. Now here we can check and see if we're on the right track. Look at these two terms in the grouping symbols. If these two quantities are equal, then we're on the right track. We can continue. If these two terms do not agree, if they're not equal, and we start with these two expressions don't agree, then that means one of two things. That means either we made a mistake on the way, or this problem is just not factorable. Since 3x minus 2 agrees with 3x minus 2, we can then conclude that 3x minus 2 is one of our factors. Now to find the other factor, we're going to look at this x and the plus 3 and put them together, and the other factor is x plus 3. This technique will work for factoring trinomials whose leading coefficient is not 1. You can check the answer if you'd like to double check. That's always a good idea. But hopefully you found this helpful. Thank you for watching the video.